This video introduces XploreML, an interactive approach to study and explore machine learning models. XploreML is an interactive tool running inside a web browser. It addresses students, lecturers, practitioners, and engineers, and it allows to explore different classifiers, their hyperparameters, data preparation steps, and different data sets. On the left-hand side, we can configure the machine learning pipeline. For example, we can select from different data sets. We can define the scaling method for the data. We can transform the data using PCA. And we can select from a number of different classifiers like KNN, random forest, XGBoost, neural networks, support vector machines. Now we selected the well-known Vine dataset, which is a dataset with 13 input attributes. And what we'll do now is to first visualize the data to understand how well the classes are separable. We can do that using, for example, parallel coordinates plot, or we can investigate the class separability with different density plots, showing that the classes do overlap in the individual features. Now, in addition, we can investigate the correlation between the different features using the correlation matrix. And we can have a look at the feature importance, which is determined using random forest, which means in order to classify the data, the most important feature was found to be proline, followed by color intensity, and so on. Using this Vine dataset, we can select different classifiers. For example, here we selected the random forest classifier and investigate the classification results. What we get here are the results on the test set, which is 98% overall accuracy, and this is the result on the train set, which means the resubstitution error. We can experiment with a classifier's hyperparameters. For example, here we use support vector machines with an RBF kernel, and we transform the data to a two-dimensional space using PCA. The support vector machine has two hyperparameters, which is sigma, the kernel parameter, and c. So on the bottom we can see the classification accuracy on the train set and on the test set. So as we change the hyperparameter sigma, which is basically the width of the Gaussian distribution in the kernel, we can see that the decision function changes, and we're now at a classification accuracy of just above 50%. Now as we increase the sigma, we can see the decision function is instantly recalculated, and here it appears to move towards some sort of overfitting, and so we can, for example, isolate one hyperparameter and understand its effects, or we can change multiple hyperparameters and see the effects on the decision function and the classification accuracy. To show the effect of scaling input data, we have selected the k-nearest neighbor classifier and a data set with one circle surrounding the other with highly different scales of the input data. Now if we just classify that data set, we can see we have quite a lot of misclassifications, as we can see here in the feature space showing the classified data points. Now if we simply rescale the input data, for example using min-max scaling, we can see that now KNN can easily separate the data set. Thank you for watching the video. You're invited to test XploreML. Please find the link in the text below the video.